Welcome to Science Access. In today's class, we'll be talking about chemical equilibrium. If you know you are new to this channel, please kindly subscribe and put on the notification button so that you get notified when I post a new video. Right? So when you talk about chemical equilibrium as a state of a system involves when there is no observable change in that system over time. There is no observable, remember the word, no observable change in the system over time. So for example, we have ammonium chloride. Now this ammonium chloride can decompose to give ammonia and what? HCl. Now realize that this reaction can move forward to form this and this ammonium and hydrochloric acid or hydrogen chloride can also combine to form what? Ammonium chloride. So this reaction can move in the forward direction and can move in backward direction. So you realize that there is a state, if this system is in a closed system, such that you are not imputing any material, you realize that there is a state you get to where the concentration of this and the concentration of this and of this in that closed system will be constant. Because the amount of this and this there, they are actually constant, all right? That state in which there is no observable change in the system over time is called what? Chemical equilibrium. But now let's deviate a little bit. It's not as if there is no change occurring in this system. This system, ammonium chloride, is actually being decomposed to form what? Ammonia and hydrogen chloride. While hydrogen chloride is being combined with ammonium to what? Form what? Ammonium chloride. You realize that this system, the rate at which this forward reaction is happening is equal to the rate at which this backward reaction is actually happening. That means the concentration of this ammonium chloride in the system remain the same over time. The concentration of this remain the same. The concentration of this remain the same. This system in which the forward reaction is equal to the backward reaction, this system is said to be in a dynamic equilibrium. So when we talk about the real state of equilibrium, the system is actually in a state of a dynamic equilibrium, where the forward reaction is equal to the backward reaction, and the concentration of the reactant and the product are actually the same over time. So this system is said to be in a dynamic equilibrium. It's a very simple concept. Note that there are properties of system in equilibrium. For example, equilibrium can only occur in a closed system. You know that is one of the properties. Another thing you should know about equilibrium is that it can only be addressed in the forward and in the backward system. For example, in the forward reaction, it's being said that ammonium chloride is decomposing to form ammonium and hydrogen chloride. While the backward reaction is being said ammonium is combined with hydrogen chloride to form what? So it can be approached from both the forward and the backward reaction. Also note that equilibrium is dynamic. I've explained that before. It's dynamic in such a way that the rate of the forward reaction is equal to the rate of the backward reaction. All right, so please take note of that. Take note of that. Note that this is ammonium chloride and this is ammonia. Please take note of that. Ammonia is combining with hydrogen chloride to form ammonium chloride. Why ammonium chloride can decompose in the forward reaction to form ammonia and HCl, which is hydrogen chloride. Note that. All right. So the last properties of a system in equilibrium that I'm going to talk about is the catalyst. Catalyst actually does not affect the rate of chemical reaction. What it does is actually it hastens up the time at which the chemical reaction actually attain equilibrium. So please take note of that. Catalyst actually hastens the time or fasten the time at which the chemical reaction attain equilibrium. Now, we have been talking about reversible reaction. What do you understand by the term reversible reaction? Reversible reaction is a kind of reaction in which the reactant can form the product and the product itself can react to form the reactant. Take note of this definition again. A reversible reaction is a situation whereby the reactant can carry out a forward reaction to produce or to form the what product, in this case ammonia and hydrogen chloride, and the product can also undergo a reversible what, backward reaction to form what the reactant. So that is what a reversible reaction, and it's actually what keeps the system in a dynamic what equilibrium. There's a unique thing, there's a principle called the chatelier principle that is often what's used in a system in equilibrium. Let's assume that this system is in a closed, let's assume that this is a closed system. So let's use this simple illustration to explain the chatelier principle. It simply says that a system in equilibrium, if there is an interference in a system in equilibrium, for example, if I want to interfere with this system in equilibrium, what will I do? I can decide to put more ammonium or chloride. That's an interference. I can decide to what? Increase the temperature. That's an interference. Or even increase the pressure. That's an interference. So if there is an interference in a system in equilibrium, the system itself, the closed system itself, adjusts in such a way that to neutralize that interference. Let me explain it this way. If I decide to put more ammonium chloride, so I have interfered with this system in equilibrium. What will the system do to neutralize it? It will favor the forward reaction. It will act in such a way that to reduce this ammonium chloride that are actually imputed into the system. So it will now favor the forward reaction, producing more what? Ammonia and hydrogen what? Chloride. So in a system in equilibrium, if there is an interference, the system move or react in such a way that will what? Neutralize it. How is it neutralizing me adding more ammonium chloride? It converts the ammonium chloride to what? Ammonia and what? Hydrogen what? Chloride. In this way, it has neutralized the quantity of what? Ammonium chloride that actually added into the system. To have reduced it. The system have reduced it itself. So the system is neutralizing my interference. It's a very simple concept. There are some factors that affect the system in equilibrium. So let's quickly talk about some of these factors that affect the system in equilibrium. Factors that affect a system in equilibrium. In equilibrium, one of them is actually what? Temperature or change in temperature. Number two, pressure. Three is what? Concentration, change in concentration of either the reactant or the product. And number four is actually what? Catalyst, which in general actually does not actually it does not affect the rate of chemical reaction. I will talk about that when we get there. So let's start with the first system in equilibrium. All right. Note that how does temperature affect the rate of chemical reaction and how will the system react? Now note that this system in equilibrium, if I decide to increase the temperature, what will the system do? To neutralize this increase in temperature, the system will act in such a way that to what? Reduce the temperature. That is what the system will do. It will act, it will react in such a way that the temperature will be what? Reduced. How does it do that? Simple. Remember, how many molecules do we have here? We have one molecule this way and two this way. If the system decides to produce, if the system have fewer molecules in general, the system, there will be less collision. There will be less collision and less heat will be produced. So the system will react, if I now increase the temperature of this place, the system will react in such a way that will reduce the number of what molecules in this system. So it will be favoring the production of what? Ammonium chloride. The equilibrium, in chemistry, we use the word. The equilibrium position will shift to what? What will you call this side? We call this side the right, and this is left. So the equilibrium position will shift depending on your position. But just know that it will favor what? The backward reaction. This is the backward reaction. To favor increase in temperature will actually favor backward reaction because two molecules will now combine together to forming what? One molecule. So the overall number of molecules in the system is being reduced. And if the overall molecule in the system is being reduced, there will be less pollution and temperature will be what? Gradually what? Reducing. What about if you now reduce the temperature? It will favor the forward reaction such that ammonium chloride will be producing ammonia and what? Hydrogen what? Chloride. Now, if more of this is produced, more molecules is inside the system because one molecule is producing two molecules. So there will be more collision and temperature of the system will be increasing what? Gradually. So the system is acting in such a way. You reduce the temperature, the system is trying to increase the temperature itself by producing more molecule and there is now more collision and we now have gradual increase in temperature. The next thing is what? Pressure. Again, if I increase the pressure of this system, the system will want to reduce the pressure. It's not true. Again, the system will produce, so reduce the pressure. What will the system do? Produce fewer molecules. It will favor the backward reactions. What about if I now increase the pressure? So if I reduce the pressure, if I, again, please, let's go through this again. If I increase the pressure, the system will favor the backward reaction because you want to lower the pressure. Two molecules combining to produce one. But if I now decrease the pressure, the system will favor the reaction that will produce more molecules so that more collision will be happening. The pressure of the system will what? More molecule we have in the system, the increase in pressure, just the way you have in a room. If you have two individuals in a room, there's space. What about if you have 50 individuals? The pressure there will definitely what increase. So if you decrease the pressure, it will favor the forward reaction because one molecule will be producing two. There will now be more molecule in this system. And there will now be what? Increase in pressure. Because you decrease the pressure, the system is acting to what? Increase the pressure. And what is the effect of concentration? If I decide to interfere with this system by adding ammonium what? Chloride, what will the system do? The system will simple. To change this ammonium chloride to what? Ammonia and what? Hydrogen chloride. So the equilibrium position will what? Shift to the what? Or will favor what? The forward reaction. In other words, if I decide to face the board, I will say it will shift to what? The right. Why? If I decide to what? Reduce the quantity of ammonium chloride in the system, what would the equilibrium position shift to? If I reduce the ammonium, it will definitely what? Shift to what? The left. If I decide to face the ball, it will shift to what? The left. Or it will favor what? The backward what? Reaction. So it's a very simple concept. What about if we now remove ammonia or we remove what? Hydrogen chloride from the system? The equilibrium position will also what? Shift to what? The right. If I decide to face the ball, this will be our right. So it will shift towards the right. But why if I decide to what? Add more this to also shift to the right. So there are various ways you can just play with this. There are various ways you can play with this. If I even add more of the product, the equilibrium position will shift backward to favor what? The backward reaction. And the last thing we are going to talk about is catalyst. It's catalyst. The effect of catalyst. Now, overall, catalyst does not what? Affect the system. I've said that before. What it does is actually it hastening up the rate at which this system attain or this closed system attain equilibrium. So that's a very simple concept. This is an introductory class. We'll talk more about equilibrium and some other aspects of this topic in another video. Thank you for watching. Please subscribe.